So today we'll be discussing conic section. Here in the image, as the plane intersects the cone, it forms different images of conic sections. So let's discuss each one by one. Or how are circles formed? Now if we have an axis here, now if the plane intersects the cone wherein the plane is perpendicular to the axis, the image that will be formed, or the conic section that will be formed, is a circle. Now if we try to tilt the plane wherein the plane is not perpendicular to the axis, now the form that will be formed is an ellipse. Now parabolas are formed by the intersection of the plane and only one part of the two cones. Also, that take note that the plane should be parallel to one of the sides of the cone. So as you can see here, the plane only intersects the upper part of the cone, this part, and the plane is parallel to the side. So that is how parabolas are formed. And lastly, the hyperbola. The hyperbola is formed when the plane intersects the two cones, as you can see here in this image. So that is how the conic sections are formed. Now, what if the plane passes through the vertex? Now, if the plane passes through the vertex, now we have what we call the degenerate conics. So degenerate conics are formed when the plane intersects the cone at the vertex. Okay, so first example is if the plane is perpendicular to the axis and it is parallel, or if the plane intersects the cone into and it is perpendicular to the axis, now the conic section that will be formed would be a point, a single point. Now if the plane intersects the cone wherein it is parallel to this side, so the image that will be formed is a single line. And then if the plane intersects the cone and it also passes through the origin, then we have the intersecting lines. You can also see that in this in the first part. Okay, so as the plane intersects the cone, as you can see, there's the intersecting line, there's the single line, and there's the point. There's the hyperbola, there's the intersecting line, there's the single line, there's the point. Then circle, ellipse, parabolas, and hyperbolas. So those are the conic sections and the degenerate conics. So the general equation of a conic section is denoted as ax squared plus bxy plus cy squared plus dx plus ey plus f equals 0. Now a, b, c, d, e, and f must be an integer, are all integers. And a, b, and c must not be equal to 0. So bakit kaya hindi pwede maging equal sa 0 si a, b, and c? Now if a, b, and c will have a numerical coefficient of 0, then ang maiwan na lang would be dx, ey plus f equals 0, which is an equation of a line. Okay, So A, B, C, D, E, and F could be any integer, and A, B, and C must not be equal to 0. So using the general equation of the line, how can we know if the given conic section is a circle, a parabola, an ellipse, or a hyperbola? Okay, so in order to do that very fast, we only need to look at the values of A and C. Okay, so to know whether the equation is a circle, A must be equal to C. So A and C should have the same values. To note that the conic section is a circle, and they must not be equal to 0. Okay? And then for ellipse, A should not be equal to C, wherein their product must be greater than 0, or A and C should have the same sign. So they should be the same, they should be both positive or both negative. For parabolas, so it's either A is equal to 0 or C is equal to 0, but not both. So one of A or C should be equal to 0, but not both of them. And for hyperbola, the products of A and C must be less than 0, meaning they have a different sign. So one must be negative and one must be positive. So that's how you know whether the given equation of a conic section is a circle, a parabola, an ellipse, or hyperbola.